right, in this lesson we're going to talk about graphing basic sine and cosine functions. And this is an equation for the sine curve in standard form. And it's similar to y equals ax squared plus bx plus c. That's standard form for a quadratic. But for a sine function, we have a sine b of x minus c plus d. And so let's talk about just briefly what these letters could mean. Well, when we had an a for a quadratic in front of the quadratic, that was the vertical stretch or shrink factor. Okay, and when we had a plus d here, so this is going to be the vertical stretch or shrink, depending upon its value. The d is the vertical shift. That means up or down. And this in here would be dealing with the horizontal situation. Okay, and with the trig function, that's a little bit different, and we call it, other than a horizontal shift, we call it a fancier name. And we call the c here is the horizontal shift. Otherwise known as the phase shift, to be fancier. The phase shift. And the b here is the horizontal stretch or shrink factor. And I liken it to the accordion effect. You know, like, is this curve going to be scrunched together or stretched out? Okay, and I also referred to this as the period factor. Okay, it's the period factor. Okay, so we have some definitions here for the vertical stretch or shrink, and we call that the amplitude. And the amplitude is the absolute value, because this could be a negative number or a positive number, just like a on a quadratic could be positive or negative. But the amplitude is going to be what we call, absolute value is going to be what we recall the vertical stretch or shrink, but it's this defined by absolute value of a, and that we use absolute value. Sorry, it's taking a few minutes for me to warm up here, because it's actually the distance between the midline of this curve and the max or the min. Okay, so the vertical shift d is what we call the midline. Okay, and in this curve here, I've got, this is the sine curve. And how did we generate this? Well, what we did was we plotted all the y values of the unit circle and created a curve. So the y value on the unit circle at angle 0 is 0. And then at pi over 2, the sine of pi over 2 is 1. And then the sine of pi is 0. The sine of 3 pi over 2 is -1. And the sine of 2 pi is 0. And what happens is when you go around the unit circle one more time, the curve repeats itself. And it goes on infinitely, because you can have infinitely many times around the unit circle gives you infinitely many angles. Anyway, this curve alternates or oscillates between -1 and 1. And in the middle is something we call the midline here. And I'm going to put a dashed line here for this. This is the midline. Okay, and the midline is always y equals d. And that would be your vertical shift up or down. Okay, now by definition, it turns out that this right here, this distance here, and this distance here, those are called the amplitude. And they have a value, this distance has a value, it's the absolute value of A. Okay, and that's the distance between the midline and the maximum and the minimum. Okay, now the period is the distance that it takes for a sine or a cosine curve to go through one complete cycle. Now, what do I mean by that? It's like one time around the unit circle, where I go from 0 to 2 pi, that's one up down cycle on the sine curve. And that's the period. And in this case, it's 2 pi. Okay. Now, I said something about up here about B being the horizontal stretch and shrink factor. And in this case, the B, which happens to always be the coefficient of the x, is 1. And when the coefficient of the x is 1, the period is 2 pi. It's unaffected. All right, but what happens when we change B is that we either stretch it or shrink it, and with the period factor. And so the period, by definition, is 2 pi over the period factor. Okay, and this is the distance between, the distance of one complete cycle. And if B is 1, it's going to be one time around the unit circle, okay? And then the amplitude, as I mentioned earlier, is the distance between the midline and the max or min of the curve, okay? Now, I'm going to define something called the increment. And the increment is going to be the distance between something I call critical points. Okay, now critical points on this curve occur when your curve is on the midline, at a maximum. This is a midline, and this is a minimum, and this is the midline. Now, I call those critical points because you can graph any sine or cosine function if you know the 5 critical points in each cycle. Okay, so if you know where your curve is going to hit the midline and you know the maximum and the minimum, then you can graph any sine or any cosine curve for that matter. Okay, and each critical point here is separated by an increment. Okay, so how many increments do we have in a period? Well, how many quadrants do we have in the unit circle? Well, we absolutely have 4. So you're going to have 4 increments in each period. So this is an increment. All right, so the increment then is going to be the period divided by 4. And the increment, by definition, as I stated, let's get rid of this, is going to be the distance between critical points. Okay, and the critical points, I'm skipping ahead a little bit here, where there are 5 of them. There are always 5 critical points. So I'm going to do my 5 sets of parentheses here. And that's when your sine or cosine curve is on the midline. So let's label our critical points here for the sine curve. Well, the first one happens to be 0, 0. The second one is at pi over 2, 1. And then pi, 0. And then 3 pi over 2, negative 1. And then 2 pi, 0. Okay, so these critical points are separated by an increment. So if I were to start at 0, I add an increment and I get to pi over 2. I add another increment and I get to pi. I add another increment, I get to 3 pi over 2, and another increment and I get to 2 pi. Okay, which is the story on how we're going to graph these pretty quickly, okay, by hand. Now, the phase shift. This is the horizontal shift. Oops. From the y-axis, just like it would be with a parabola, shifting left or right. Okay, and that's going to be C. And then the midline is y equals D. And the midline is the average of the max and min. Where you would say the max value, the max y value, plus the minimum y value, and you divide it by 2, and that's going to get you D. Okay? So these curves are very easy to draw. They're repetitious because you can go around the unit circle multiple times. And the domain on this function, I should put the domain here, is all real numbers. The range, in this case, is -1 to 1 inclusive. And this has extreme values. It has absolute maxes and absolute minimums. And they occur, this absolute max occurs every 2 pi. And this absolute min occurs every 2 pi. And we call them periodic functions because they repeat exactly the same shape, size, every period. So let's look at the cosine curve really quickly and see what the difference is. Okay, this is the cosine curve. Again, in standard equation form, it's a cosine b times x minus c plus d, where a, absolute value of a, is the amplitude. So I'm going to put this right here. Absolute value of a is the amplitude. B is, again, the period factor, so that the period would be 2 pi over b. The increment is still and always will be the period over 4, because we have 4 quadrants. The phase shift is going to be the horizontal shift from the y-axis, and that's going to be C in this case. The midline will be y equals D. And the critical points, now let's label the critical points here. That's when you are on the midline or at a maximum or a minimum. And the midline in this cosine curve, let's graph that. The midline here, the plus D here is 0. So the midline on this curve is 0. And I left off this increment here. Okay, so let's do our critical points. Our critical points on the cosine curve, there are 5 of them, just like the sine. 1, 2, 3, 4, 5. Okay, and we're going to start at our first point here, which is 0, 1. Because the cosine of 0 is 1. The x value at the angle 0 is 1. Then we walk an increment over, and that's pi over 2. So this is pi over 2, comma 0. 0. And then we add another increment, and we get to pi, and we're at -1. Add another increment, we're at 3 pi over 2, 0. And then add the last increment, we get 2 pi, 1. Okay, and just like the sine curve, the distance between the midline and the max is the amplitude. And the distance between the midline and the minimum is the amplitude. I'm not going to write the definitions again here because you have them here, because these are all the same as they are for the cosine curve. Here, the definitions. Okay, and the increment is still between critical points. Do you see the increment here? And how many of them do we have? Again, we have 4 of them. And we don't have a phase shift here because we started on the y-axis. And our midline is D, and in this case we have D is 0. And all of this, if this sounds a little crazy, will make a whole lot of sense when we do a lot of practice problems, okay? All right, keep moving here. So I wanted to make a note as to the differences of the sine and the cosine curve when we're graphing them. Now I've got one period, one up-down cycle here, and with the cosine curve, you start at a high spot, go low, and then end up at a high spot, and then it repeats itself again, okay? I wanted you to make a note the difference here. And if you notice, one of these, I'm going to draw the midline specifically on both of these. If you notice that the sine curve, when you're graphing it, always starts on, the first critical point is going to be always on the midline. Okay? Always on the midline when you're graphing it. When you're going to graph a cosine curve, I would like you to notice that you're going to be off the midline. And you're going to be off the midline either up in amplitude or down in amplitude, depending upon whether your curve is negative or positive. Okay, so you're always going to be off and up or off and down. Okay, and sine always starts on the midline, regardless if it's a positive sine curve or a negative sine curve. Okay, so that's important to remember. Sine on, cosine is off when it starts. All right. Let's do another. So what we're going to do here is see if we can look at a curve and identify what its features are based on the equation, okay? And the curve here. So I have 3 cosine of x plus 1. All right, so I'm going to identify the attributes here. What do we have here? Well, this here is a. B is the coefficient of the x, which in this case is 1. And I don't have a C, because if I had a C, I'd have a set of parentheses. And then this here is D. Okay? So D, I like to start off right away with, is my vertical, my vertical shift. So that means the midline went up 1. So I would come down here and say, okay, well, my midline is y equals 1. All right? Now, the amplitude is the distance between the high spot and the midline. So this is the amplitude. And if you look at the graph, it certainly looks like it's 3. So it's going to be absolute value of 3, which is 3. Okay, the period. Well, the period is the distance on the cosine curve between the high spot and the high spot here. Because you see, I drew 2 cycles of this curve here. But I drew, the one that I see here is the one that does not have a phase shift. So it's starting at here when I name it. Okay, so here we go. Here's our period. And if we look at it, it's going to be from 0 to 2 pi. And how do we determine the period? You take the x where your function is ending, and it's not really ending. I hate always saying that because it goes on forever. But the cycle that you're looking at ends at 2 pi, and then you subtract where the cycle started that you're looking at in 0. So you're going to go 2 pi minus 0. And so the period here is equal to 2 pi. Okay. And does that make sense? Well, what's the period factor here? The period factor is b, and the b, which is the coefficient of the x, is 1. So I always say here b equals 1. And so the period is going to be 2 pi over 1, which is 2 pi. And we would expect that by looking at the equation, and sure enough, looking at the graph, that it works that way. Now the increment is always, as I stated, the period over 4. Okay, well, what is the period? Well, the period is 2 pi, and I divide that by 4, I get pi over 2. So our increment is pi over 2. Let's see, if I start at 0, and I go to the next critical point, because the critical points are the points that are at maxes, on the midline, minimums, on the midline, or at maximums again. So my critical points for this graph are going to start at y equals 0. X equals 0. So I don't have a phase shift. So my phase shift is 0. And the critical points for this curve, if I were to read them off the graph, how many of them are there? Well, there are 5. So the first one's going to be at 0, 4, and then pi over 2, because that's an increment away, because the increment's pi over 2, 1. Then I add an increment to this, which means it's going to be pi. At pi, we're at -2. And then I add another increment, so at 3 pi over 2, our graph is at 1 again. And then at 2 pi, we're at our maximum of 4 again. Okay, so we can actually figure out what these attributes of the curve are, and then we could go back and graph them. Without having looked at this, we can figure out what this information is, these properties or characteristics, just from the curve, and then graph this pretty easily. I'm going to do a lot of examples of that, okay? So what about this sine curve here? So without looking at the curve, and I don't know if I have something that'll cover it up here. We can look at my fun facts here about jelly beans. Without looking at the curve, okay, we would say the amplitude is what? That's A, because this is A. B is the coefficient in front of the X. This is now C, and this is D, right? Okay, so we know that A is 3. So the amplitude is the absolute value of A, which is 3. The period, well, the period factor here, B, is equal to 1. And the period is always 2 pi over B, so 2 pi over 1, which is 2 pi. The increment is going to be the period over 4, because we have 4 quadrants. So this is 2 pi over 4, which is pi over 2. The phase shift here is, well, it's always x minus c, okay? And I like to think about the phase shift as to whatever this parentheses, when does that become 0? Well, that becomes 0 when x is pi over 2. So when my phase shift is going to be a positive pi over 2. And if you think about a transformation with quadratics or any of our toolkit functions, when this is subtracting, this is a shift to the right. And how I think about this is that what makes this 0? Well, what makes it 0 is pi over 2, a positive pi over 2, okay? Which makes it different than, now this is a cosine curve. This has no phase shift. And what makes this x 0? Well, what makes this x 0 0, so I'm starting at x equals 0. What makes this x minus pi over 2 0 is a positive pi over 2, which means I'm starting at a positive pi over 2, okay? The midline is D, which is y equals -1. And the critical points, well, where do we start? Plotting our points. Well, I like to think about the phase shift, because the phase shift is where you are in relation to the y-axis. And I always like jokingly say, please start PS at the phase shift. So we're going to start at pi over 2. And how do we get to the next critical point? Well, we add an increment. So what happens when I add pi over 2 to pi over 2? Well, you get pi. And what happens then if you add pi over 2 to pi? Well, you get 3 pi over 2. If I add pi over 2 to 3 pi over 2, because that's how we get to the next critical point, is add an increment, 3 pi over 2 and pi over 2, it's 4 pi over 2, which is 2 pi. And then 4 pi over 2 plus pi over 2 is 5 pi over 2. Okay? Now, this is a cosine curve. So on a cosine curve, what do? Do you start on or off the midline? Well, cosine starts off the midline and up in amplitude. Okay, so let's see. Cosine starts off and up in amplitude. Well, if my midline is -1, if I add 3 to -1, I get 2. So I'm going to start at 2. And then I'm going to go back to the midline. I go from my high point to my low point. So this is going to be -1. And then I'm going to go down in amplitude. So this will be -4. And then back to the midline and then up to my high point again. And let's see if that's what the curve says. Okay, now where did we say we were going to start? We were going to start at pi over 2, which is right here. Well, and then is that pi over 2 too? Sure. And then my next critical point is going to be here at pi, which is pi -1. My next critical point is 3 pi over 2, -4. And then 2 pi, we're back on the midline, and then 5 pi over 2, we would be at a maximum again if we had seen the complete, cycle here, okay? Now, if you're a little confused as to, why I started at pi over 2, well, this curve, believe it or not, could be named infinitely many names. With parabolas and cubics and square root functions, and you can only name them specifically one name with a transformation. But since this curve has infinitely many cycles, I could name this curve infinitely many names. Okay, and the name or the equation for this curve that they gave us was 3 cosine x minus pi over 2 plus 1 minus 1, which was talking about the piece of the curve that is right here that I have in this peachy color here. Okay, could I have named it a name? Sure, I could have had my phase shift here be at 3 pi over 2, right? Negative 3 pi over 2. Is this the same curve? It has different critical points. Sure does, doesn't it? Sure does, but is it the same curve if I say f of x is also equal to, well, what's the amplitude of this curve? Well, it's definitely 3 cosine, and does it have the same period? Sure. So the period factor still will be the same, and instead of x minus pi over 2, this would be a phase shift of -3 pi over 2, so this would be plus 3 pi over 2 minus 1. And this curve is the same exact curve as this one. It's just written with a different phase shift. Okay, so I wanted to make it clear that, yes, this curve can be drawn by the peach colored with this representation, but it also has an equivalent equation with a different phase shift. So that's pretty cool, I think. Okay, all right. So here we are. We're going to graph this curve, just taking all the details off of this, okay? Off this equation. So what is A? Well, A is 1 here because that's the coefficient of the cosine. So the amplitude is the absolute value of 1, which is 1. The period factor B is 1, and that's always the coefficient of the x. And so the period is going to be 2 pi over 1, which is 2 pi. The increment is always the period over 4, and that'll be 2 pi over 4, which is pi over 2. The phase shift, now, this is not in parentheses here, so this is the only angle, and then this has to be D. So I know the midline's got to be y equals 2, because that's the vertical shift. I have no phase shift because this x minus c, the c is 0 here. And now I'm going to write how many critical points? Yes, 5 critical points. And where are we going to start? We're going to please start at the phase shift. And the phase shift here is 0. Now, how do we get to the next critical point? Well, of course, we add an increment. So 0 plus pi over 2 is pi over 2. Pi over 2 plus pi over 2 is pi. Pi plus pi over 2 is 3 pi over 2. Plus another pi over 2 is 2 pi. Okay? Now, I always put the y values in here last after I graph the curve. Okay, so here we go. We're going to graph the curve. This is my xy coordinate plane. And my first critical point is 0. And I'm going to lay down the midline. And the midline here is 2. So I'm going to go up 2. Label this. And my amplitude is 1. So I know I'm going to go up 1 and down 1. So this is 1 and this is 3. And I'm going to draw my midline here. Here's my midline at 2. And then I lay down the x-axis. So this is 0, and then I put the first point and the last point. Because for me, it's easier to make the interval uniform by looking at this and then seeing what the middle looks like it could be. That's pi, and the middle one's always the third point. And then I go halvesies again, and that's going to be pi over 2 here, and then 3 pi over 2 here. So I draw the whole interval, cut it in half, and then cut this one in half, and then cut this one in half. All right, and now we're going to graph our critical points. Now, this critical point here starts at 0, but this is a cosine curve, and cosine starts off the midline and up in amplitude if it's positive, so I'm going to start up here. Then I go back to the midline, then I go down in amplitude, and then back to the midline, and then up in amplitude. Okay, and then I connect the dots. And there's my cosine curve. Okay, and now I'm going to pick the y values off of here. So it would be 0, 3 is a critical point, pi over 2, 2, pi, 1, 3 pi over 2, 2, 2 pi, 3. And the domain on this function is all real numbers, because any angle will work inside of a cosine. And the range is going to be from 1 to 3 inclusive. Okay. All right, let's do another one. This is sine. Okay, let's look at the equation. Well, A is 2, so the amplitude is the absolute value of 2, which is 2. The period factor in this case, B, is 1. Remember, the period factor is the coefficient of the x. Okay, so the period is 2 pi over B, and that's just 2 pi. The increment here is the period over 4, which is going to be 2 pi over 4, which is pi over 2. The phase shift now, I have a phase shift here because I have an angle that's not 0 when x is 0. When is this 0? Well, the phase shift is going to be a positive pi over 2, which means I'm shifted to in the positive direction, pi over 2. The midline, do I have a plus d here? No, so the midline is y equals 0. The critical points, how many do we have? We have 5. And where are we going to start? Well, yes, we're going to please start at the phase shift, and we're going to put pi over 2 here. And how do we get to the next critical point? Well, we add an increment. So pi over 2 plus pi over 2 is pi. Pi over 2 plus pi is 3 pi over 2. 3 pi over 2 plus pi over 2 is 2 pi. 2 pi plus pi over 2 is 5 pi over 2. And I'm going to graph my curve here, xy plane. What's my midline here? Well, my midline is 0. There it is. There's my midline. And my amplitude in this case is 2. So I'm going to go up 2 above it and 2 below it. And this is 0. Okay, and now I lay down my x values or my angle values. And I'm going to start at pi over 2. And I'm going to end at 5 pi over 2. And then in the middle is going to be what value? Well, that's 3 pi over 2. Whoop. And then pi. And then 2 pi. Okay, now I'm going to decide what kind of curve I have. What kind do I have? It's a sine curve. Sine starts on the midline and at my critical point. So on the midline at my critical point. And since this is a positive sine curve, it's going to go up in amplitude to 2, Then it's going to go back to the midline, and then down in amplitude, and then back to the midline. And here we go. Graph by connecting all of the dots here. And there's my sine curve. Now, let's pick the y values off the graph. I get pi over 2, 0, pi, 2, 3 pi over 2, 0, 2 pi, negative 2, and then 5 pi over 2 is 0. The domain on this function, the angles possible are all real numbers, and the range is going to be negative 2 to 2 inclusive. Okay, let's do another one. All right, now this one gets a little bit more complicated because now we have a period factor here that's 2, not 1. So let's see what happens. But the amplitude here is 3, or the A is 3. So the amplitude is the absolute value of 3, which is 3. The period factor now I have changed is now 2. And the period is going to be 2 pi over 2, which is now just pi. And the increment is going to be still the period over 4, which is equal to pi over 4 in this case. The phase shift. Now this is the angle. Do I have any minus c in here or plus c? I don't. And I don't have any midline. So the phase shift is 0. The midline is y equals 0. And how many critical points do we have? Well, we still have 5. And we're going to please start at our phase shift, which is 0. And then how do I get to the next critical point? Well, we're going to add pi over 4. So 0 plus pi over 4 is pi over 4. Now, this is where I'm going to tell you that I am just interested at this point in you being able to graph the graph, and I'm not as interested in you being able to reduce the fractions. So if I'm adding pi over 4 to pi over 4, we're going to get 2 pi over 4. Now, do I know that that's pi over 2? Yes. But for speed in which to draw this, I'm going to say 0, pi over 4, 2 pi over 4, add another one, which is 3 pi over 4, add another pi over 4, and we get 4 pi over 4. And I would just leave them because I know that you can reduce this to pi over 2 and this to pi. It just is quicker for our analysis, okay? So here we go. I'm going to draw my xy plane. My midline is 0, so here it is. Here's my midline, 0. My amplitude is 3, so I'm going to go up 3 from the midline and down 3 from the midline. So this is negative 3 to 3 here. And I'm going to lay down my x values at 0, and then I'm going to put 4 pi over 4 here. And then what's in the middle? That would be 2 pi over 4. And then pi over 4. And then 3 pi over 4 here. And then the critical points, this is a sine curve. So sine starts on the midline at my phase shift, which is 0. And it's a positive sine curve, so it's going to go up first in amplitude, back to the midline, down in amplitude, and back to the midline. If I connect the dots, that's what it looks like. Now, what's happened here? The period, what we're used to in the last few examples, was 2 pi. So what has this 2 done? Well, it's been the accordion effect, and it took the horizontal graph and squeezed it in, so to speak. So horizontally, it squeezed an entire sine curve into half of the distance. So when this is 2, that means you're actually shrinking the period, which makes sense, right? Because this you divide by 2, and that's making the period half as big. So, all right, so let's do one last thing and do our y values. The critical point y values are 0, 3, 0, negative 3, and 0. Our domain here is our real numbers. The range, in this case, is negative 3 to 3 inclusive. Okay? All right, here we go. Let's amp it up. So if this takes the period and shrinks it by half, what do you suppose is going to happen to this one if I am taking, and b is 1/2? It's going to take the period that was 2 pi and stretch it by 2. Okay, so let's look at the properties of the curve here. The amplitude is going to be the absolute value of -2 now, which is 2, and this is now negative. So we need to make a mental note, with this being negative, that this curve is upside down. Now, upside down is not necessarily a mathy term, but it's reflected across. So it's reflected across which axis if it's upside down? The x-axis, okay? So that's the mathy term, okay? All right, so let's see what happens. The period, well, the period factor now, the coefficient of x over 2, because I could rewrite x over 2, could I rewrite as that equivalent to 1/2 x? It sure is. So the coefficient of the b, of the x coordinate here, or x, is 1/2. So the period factor is 1/2. And so the period is going to be 2 pi over 1/2, which means the period is now 4 pi, which has done what to the 2 pi? It has doubled it. So this accordion effect has stretched it out horizontally. But the increment is still the period over 4. So that's just going to be 4 pi over 4, or just pi. The phase shift, I don't have anything else in here on the inside the angle argument here, so the phase shift is 0. The midline in this case is 1, and the critical points, how many do we have? 5. And we're going to please start at the phase shift, so we're going to start at 0 here. And then how do we get to the next point? Well, we add an increment. The increment is pi, so this will be 0, pi, add another pi, 2 pi, another pi, 3 pi, and then 4 pi. And now I'm going to graph my curve. All right, now my midline is 1, and then I'm going to go up and down 2 from this. So this will be a 3, and this will be -1. And let's graph the midline here. And now I'm going to lay down the x-axis, which will be 0, and then this will be 4 pi. And this will be 2 pi in the middle here, and then the middle here is pi, and the middle of here is 3 pi. Okay? And now we have to make a decision when we're graphing. Where do our critical points go? Well, this is a cosine curve. A cosine curve starts off the midline, but this is negative. So instead of starting off the midline and up in amplitude, we're going to start off the midline and down in amplitude at our phase shift, which is 0. So I'm going to start down here. And then I'm going to go back to the midline, go up in amplitude now, back to the midline, and then down in amplitude. And then we're going to connect the dots. That's the fun part, I think. Now, do you notice that when I get to the minimum, I go back up on my curve, because that's what the cosine curve does. So it's going to repeat another cycle on this side and another cycle on this side. All right, so let's pick off the critical point y values. Well, the first one's going to be -1, and then midline 1, and then 3 for the max. 3 pi is 1, and then at 4 pi is -1 again. The domain in this case is still -infinity to infinity. The range is going to be -1 to 3 inclusive. See, once I get going, it's better. My mouth starts working better. Okay, so that's nice. The b factor here, when it's a fraction, actually stretches the period out, which I like. Okay, let's do another one. All right. This is a sine curve that has a b factor, a phase shift, and a midline, but the amplitude here is a simple 1, so this is absolute value 1, which is 1. The period factor here, b equals, this right here is the coefficient of the x, is 3, which is going to amp up, pardon the pun, the difficulty here, because the period is going to be 2 pi over 3 now. Okay, now the increment is going to be the period over 4, which sometimes drives students a little bit crazy. So when I have a fractional period like this, what I like to do is, instead of the period over 4, that's the same thing as going 1/4 of the period, right? It's the same thing as multiplying it by 1/4. So I'm going to take 1/4 and multiply it by 2 pi over 3, okay, which is going to be 2 pi over 12, which is pi over 6. That way I don't have to keep flip with fractions. The phase shift here, what makes this angle argument 0? That's right, negative pi over 4, which means I'm shifted in the negative direction, pi over 4. The midline here is -1, so it's y equals -1. How many critical points do we have? You're like, Mrs. Muller, you keep asking me that. Well, we have 5. Now, where are we going to start? We're going to start at the phase shift, which is negative pi over 4. But what am I adding to the phase shift? I'm adding an increment, right? Oh no, they have different denominators. So I've got to find a common denominator. Well, in this case, I'm going to suggest to you that the common denominator is 12. Okay, so I'm going to change them both to 12ths. Okay, so how do I change this to 12ths? Well, I'm going to multiply everything by 3 over 3, right? So that'll be negative 3 pi over 12. Okay, what is the increment going to be if I make the denominator 12? Well, it's going to be multiplying the top and the bottom by 2, which would be 2 pi over 12. Okay, and so we're going to start at the phase shift, which is now negative 3 pi over 12, which I know is negative pi over 4. But I'm not testing whether you can reduce fractions. I'm just testing whether you can graph the graph using increments and all of that stuff. So how do I get to the next point? Well, you add an increment. Well, what happens when I add negative 3 pi over 12 and 2 pi over 12? Well, you get negative pi over 12. And then I add another 2 pi over 12, and I get pi over 12. And then another 2 pi over 12, we get 3 pi over 12. And then another 2 pi over 12, we get 5 pi over 12. Ugly numbers, I know, but there are critical points. So we have to work with them. Okay, now, here's my axes. Now I'm down 1 with an amplitude of 1. Let's do my midline in green. I'm liking using the colored pencils here. There, whoop, it went up a little bit. Oh well. Okay, so now I'm going to go up 1, which is to 0, and down 1, which is to -1. Oh no, I'm on the left side, aren't I? So let me get rid of this, because that's not the 0 on the axis. So what am I going to put on? I'm going to put negative 3 pi over 12. And then I'm going to go over here to, if this is 3, we're going to go to 5 pi over 12 here. And then we're going to go to negative pi over 12. And pi over 12. And then 3 pi over 12. Sometimes it's hard for me, even when I've got the y-axis in the middle of all of this madness, to draw my increments and stuff, but it doesn't have to be exact, as long as they're in the right order and they look reasonable. Okay? All right, now, this is what kind of curve? Well, it's a sine curve. So a sine starts on the midline, and this is a positive sine curve, so we're going to start on the midline at our phase shift, so we're going to start on the midline at our phase shift, which is negative 3 pi over 12. And then since it's a positive sine curve, we're going to go up in amplitude, down, back to the midline, down in amplitude, and then back to the midline. And we're going to connect the dots. There you go. And now let's plug in our y values here. We get, for our critical points, -1, 0, -1, -1, 0, -1, This is -2, huh? That's hilarious that I can't label my axes, right? -2, and then back to -1. You all probably saw that and went, Mrs. Muller, what are you doing? You'd be absolutely right. All right, so the domain is -infinity to infinity. The range here is -2 to 0. And that is our lovely sine curve. So what makes this problem challenging is that when the period is 2 pi over 3, the increment is pi over 6, and our phase shift here happens to be negative pi over 4, and we had to find a common denominator in order to, get to our next critical point by adding an increment. Okay? All right, let's do another one. Oh no, this looks a little strange. The b term is not outside of the parentheses. So what was standard form? Let's refresh our memory. Oops, I wrote it up too high here. Standard form of the equation is y equals a cosine b x minus c plus d. I want you to please notice that this isn't c if the b isn't outside the x parentheses. This b needs to be outside of the parentheses. Do you see how b is inside the parentheses here? Oh, that's a troublesome situation. So I'm going to rewrite this as cosine, factor out the 2. When I do that, that's easy enough. This is x. Now this is where it gets a little confusing, but it's not difficult. If I was going to factor 2x minus 4, right? And I factored a 2 out, the GCF, and I say x, everybody knows that this would be x minus 2. What did you do to this 4 to get a 2 here? You divided. So what are we going to do here? We're going to take this 2 and we're going to divide pi by it. There you go, right? And so how do you know you're right? Well, the good news about factoring is that you can redistribute it to see if you match. So what happens when I multiply this 2 in? I get 2x minus 2 pi over 2, which is minus pi. So it works, okay? So now we can see the c because the b is factored out in front, okay? Now, let's say you forget to do that. Not that you will, but let's say you do. What makes this inside set of parentheses equal to 0? Does everybody see that if I was setting that equal to 0, 2x minus pi equals 0, we would get 2x equals pi, x equals pi over 2. Do you see how the phase shift is whatever makes the angle argument equal to 0? And that's going to be pi over 2. And do you see how it turns out that it is pi over 2? So if you ever forget, you can set the inside angle argument equal to 0 and figure out what the phase shift is. But you're not going to see or be able to look at and see the c unless the b is factored out in front. Okay, the amplitude here is 1. So absolute value of 1 is 1. The period factor here is 2. The b is equal to 2. So the period is 2 pi over 2, which is pi. The increment is the period over 4, which is pi over 4. The phase shift in this case is a positive pi over 2. The midline is 0. And the critical points here, we have 5 of them. All right. Now what am I doing? I'm adding a phase shift and an increment that have different denominators. So I'm going to change one of them. I'm going to change this one to 2 pi over 4 by multiplying it by 2 over 2. And now where do we start? Well, we please start at the phase shift, which is 2 pi over 4. And how do we get to the next critical point? Well, we add an increment. So this would be 3 pi over 4. Add another increment, 4 pi over 4, 5 pi over 4, and 6 pi over 4. All right. And now let's graph our graph. This is a cosine with no midline. Well, when I say it has a midline, but the midline has no value, right? It's y equals 0. And our amplitude is 1. So I want to go up 1 and down 1. And I'm going to label my axes now. So we're going to start at 2 pi over 4. Where are we going to end? well, we're going to end at 6 pi over 4. And then we're going to go halvesies, and we get 4 pi over 4. I don't know if that's completely in the middle, but anyway. And then 3 pi over 4, and then 5 pi over 4. And this is a cosine curve. Cosine starts, I heard it, above and up in amplitude. So we're going to start up here at 1, go to the midline, go down in amplitude to -1, back to the midline, and then up in amplitude, and we're going to connect the glorious dots here. And there's our cosine curve. Okay, the other thing I want you to notice when you're graphing this, and I haven't mentioned it, do you see how these are nice smooth curves? This doesn't come to a dot like a point, you know? It's a nice curve. It's not pointy. But anyway, okay, so what do we have here? We have the y values are 1, 0, -1, 0, and 1. The domain on sine and cosine, as always, is all real numbers. And the range, -1 to 1. All righty, another one. Uh-oh. We amped it up here a little bit. So what does this equal? This is going to equal 3 times the sine. What am I going to factor out here? I'm going to factor out a 1/2, because what you factor out whatever's in front of the x. So it's going to be 1/2 times x minus, well, if I take 1/2 out of 1/4, what do we get? We're left with a pi over 2, right? So think about it. Does that make sense? If I multiply it back in, 1/2 times x is certainly 1/2 x. And then 1/2 times pi over 2 is pi over 4. So it works, doesn't it? Okay. All right. So the amplitude is going to be absolute value of 3, which is 3. The period factor, b, equals 1/2. So that means that we're going to take 2 pi and divide it by 1/2, which is going to stretch it to 4 pi. Makes it a lot wider, okay? The increment is the period over 4. And so that's going to be 4 pi over 4, which is pi. The phase shift is now, well, what makes that 0? It's going to be a positive pi over 2. The midline in this case, again, is y equals 0. And how many critical points do I have? I have 5 critical points. It's like I want to say 5 golden rings, 5 critical points. And then where are we going to start? We're going to start at the phase shift. Well, the phase shift is pi over 2. And the increment is pi. So I'm going to change the increment into halves. So if I multiply the increment by 2 over 2, we get 2 pi over 2. Okay, so we're going to say pi over 2 plus 2 pi over 2 is 3 pi over 2. Plus 2 pi over 2, which is 5 pi over 2. Plus 2 pi over 2 is 7 pi over 2. And then 9 pi over 2. All right, now we're going to graph it. And I have my midline at 0, so let's do that. Midline is at 0. And my amplitude is 3, so we're going to go up 3 and down 3. And we're starting at pi over 2, and we're ending at 9 pi over 2. Halfway looks like right about here, which is 5 pi over 2. This would be 3, that's not quite in the middle there. And then the middle here, 7 pi, that's not quite the middle either. Oh well, I'm trying. Okay, our critical points. This is a sine curve, so it starts on the midline at my phase shift, which is pi over 2. We're going to go up in the amplitude, down in amplitude, back to the midline, down a full amplitude to the minimum, and then back to the midline, and we're going to connect our dots here. And let's take our y values off the graph here, and we get 0, 3, 0, -3, and 0. The domain, it's going to be all real numbers. The range will be -3 to 3. All right, let's do another one. Ooh, what have we done here? Well, first we've made this sine curve upside down. We reflected it across the x-axis, and we've changed the period factor to pi. So let's see what happens with that. Okay, so the amplitude is -2, absolute value of -2, which is 2. The period, the b factor is pi. So the period is going to be 2 pi over pi. Well, that's just 2. Interesting. Okay. The increment is going to still be the period over 4, which is going to be 2 over 4, or 1/2. The phase shift here is 0. The midline is y equals 1. And we have 5 critical points. I'll stop, right? maybe not. All right, here we go. We have 0. And how do I get to the next critical point? I add the increment, which is 1/2. And then add another half, we get 2 halves. Add another half, we get 3 halves. Add another half, we get 4 halves. Okay, and if I were to subtract 4 halves, which is 2, minus 0, I get 2, right? Which is my period, which is what I expect, okay? All right, so let's graph our graph. Now my midline is 1, and my amplitude is going to be 2, so I'm going to go up 2 and then down 2, so it's going to go to -1 and 1, 2, 3. All right, let's graph our midline at 1. There it is. And now we're going to graph our x values. So we're going to go to 4 over 2. Halvesies is 2 over 2. Halvesies is 1/2. And then 3 over 2. Now, notice here that our increment and our critical points now don't have pi's in them, but that's okay. Because what did we do? We divided the pi away with our period factor. All right, so this is what kind of curve? It's a sine curve that starts on the midline. There it is. There's our midline at our critical point. Phase shift critical point. And now this is a negative curve. So what do we know about it? This is upside down. And what's the fancy word mathematically? Yes, it's reflected across the x-axis. All right. So that means instead of going up in amplitude, we're going to go down in amplitude. So we're going to end up down here, back to the midline, and then up to the maximum, and then back to the midline. Okay, so here we go. Now, when I say reflected across the x-axis, that's not really right, is it? So I should erase that. I don't know if the red will erase, but there it is. It's reflected across the midline, isn't it? Right? Because if it was positive, it would go from here to here to here to here to here. So it's reflected across the midline. All right, so let's pluck the y values off the graph, and we get 1, -1, 1, 3, and then 1, and the domain here is all real numbers. The range is -1 to 3. All right, we're moving right along. Ooh, Mrs. Muller, what have we done here? Though that looks gross, but we're going to fix it, right? What are we going to do? We're going to factor out whatever the coefficient is in front of the x, no matter how ugly it is. So this is going to be cosine. 5 pi comes out. X minus, now what am I going to do with this 2 pi? I'm going to divide it by 5 pi. So up here, I'm going to, in my little calculation, I'm going to go 2 pi over 5 pi. Well, what happens to the pi's? Well, they cancel and we get what? 2/5. Plus 1. Now, how do we know we're right in that? Well, we can redistribute, right? So what happens when I multiply 5 pi times x? I get 5 pi x. Now what happens when I multiply 5 pi times 2 over 5? Well, the 5's cancel and I get 2 pi. So it works. That's okay. So what's the amplitude here? Well, the amplitude nicely is absolute value of 1, which is 1. The period factor in this case is equal to 5 pi. Gross. So the period is going to be 2 pi over 5 pi, which is 2 over 5. Interesting. The increment is the period over 4, or what did I say we do if we have a fractional period? Well, you can say it's 1/4 of 2/5. So it's 1/4 times the period as well. So that's going to be 2 over 20, or 1/10. The phase shift here is what? Well, what makes this 0 is a positive 2 over 5. The midline here is y equals 1, and I have 2, 3, 4, 5 critical points. And we're going to start at the phase shift. But wait, I'm adding a 10th to something that's the 5th. So I'm going to change this into tenths here. So how do I change this into tenths? I multiply it by 2 over 2, which is 4/10. And we're going to please start at our phase shift. So this will be 4/10. Then I add a 10th is 5/10, 6/10, 7/10. Oops, I almost put the 10 up there with the 7. And 8/10. All right, our midline is 1, and our amplitude is 1. So this is going to go up 1 and down 1 to 0 here. Okay, and our midline we said was 1. Here's our midline. So what has this 5 pi done? Well, it's taken the period that would normally be 2 pi and really shrunk it down to 2/5. So they're really pushing in on that cosine accordion. Okay, so we're starting at our phase shift, which is 4/10. And then we're going to go to 8/10. Halfway is 6/10. Halfway is 5/10. And then 7/10. And this is a cosine curve, so we're going to start off the midline, and since it's positive, it's going to be up at a max, and then to the midline, and then down, and then to the midline, and then up. And here we go, connecting our glorious dots here. And let's take our y values off the curve. We're going to get 2, 1, 0, 1, 2, the domain, all real numbers. The range is going to be 0 to 2. All right. Look at that. We did a really challenging one with the 5 pi as our b factor, our period factor. Pretty cool. All right. Last one. Now this one looks really obnoxious. I thought 5 pi was obnoxious, so this is pretty obnoxious. Okay, so what are we going to do? We're going to factor out the b factor. So this will be negative 2 sine, what do I pull out? A 2/3. And I'm left with x minus, and now I'm going to say pi, oops, sorry. This is my calculation area right here, right? Pi divided by 2/3, which is going to be 3 pi over 2. Right, because I flipped the fraction. So this will be 3 pi over 2 minus 2. Now, why is this the challenger one? Well, because I've got an amplitude, and it's upside down, a b factor, that's a fraction, a phase shift, and a midline. So I've affected the a, the b, the c, and the d. So the amplitude here is the absolute value of negative 2, which is 2. The period factor here is 2/3, so b equals 2/3. So the period is going to be 2 pi over 2/3, which would equal 2 pi times 3/2, right, which is just 3 pi. The increment is going to be 3 pi over 4. I did that right? Yep, okay. The phase shift, well, that's 3 pi over 2. It's a positive. I didn't do very many left ones. I should have done some left ones, right? How do I change the denominator here? I'm going to multiply this by 2 over 2, which is going to be 6 pi over 4. Okay, midline here is y equals -2 critical points. Now, why did I do this? Because I knew I was going to be adding an increment to this phase shift, right? Because we're going to please start at the phase shift, which is 6 pi over 4. And I'm going to add the increment, which is 3 pi over 4, so that'll be 9 pi over 4. Add 3 more, and that will be 12 pi over 4. Add 3 more, that's 15 pi over 4. Add 3 more, that's 18 pi over 4. Now let's see if we're right. 18 pi over 4 minus 6 pi over 4 is 12 pi over 4, which is 3 pi, which is what I expected. Wow, I really made this point big. Okay, so I got an amplitude of 2 and a midline of -2. So I'm going to skew this a little bit. So it's -2, -4. I'm going to go to 0 up here. Okay, midline is -2. Here it is. All right. Now I'm going to lay out my x values. So I'm going to say 6 pi over 4. And then 18 pi over 4. The middle here is 12 pi over 4. The middle here is 9 pi over 4. And then 15 pi over 4. All right, this is what kind of curve? Well, it is a sine curve. And sines always start on the midline at our phase shift. And now this is negative, right? This is upside down, or reflected across its midline. Okay, so instead of going up in amplitude, we're going to go down to -4, back to midline, up in amplitude, and then back to the midline. And then we're going to connect our points. Here we go. That's a little pointy there. It should be more smooth, but okay. Now let's pick our y values off the curve here. We get -2, -4, -2, 0, and -2. Domain. All real numbers. The range goes from -4 to 0 inclusive. And there we go. There's our curve with our challenger, the A, B, the C, and the D all affected. All right, now what we're going to do is something I like to call name that curve, where I give you a curve that doesn't have an equation, and we're going to come up with the equation for it. I'm going to name that equation. All right, so the very first thing I like to do is figure out what the midline is, because if you know what the midline is, you at least know where D is, and if you know what D is, you can calculate the amplitude. Okay, so what's the maximum? Remember how I said you can calculate the midline. What do? You take the max and the min and you average them. So the maximum here is 4. The minimum is -2. So 4 plus -2 is 2, divided by 2 is 1. So the average of those is 1. So the midline here is 1. And if you look at the curve, when you graph it, do you see that it looks reasonable that the midline is 1? Okay, so if the midline is 1, that means I know D. So what is D? D has to be 1. All right, and I know that the amplitude is going to be the distance between the midline and the high spot. Well, that's going to be 3. So A is going to equal, I should say, absolute value of A is 3, right? Because we could name a positive curve or a negative curve. Okay, so let's name a sine curve first. Now, when I'm naming that curve, what I like to do is actually highlight the curve I'm going to name. Okay, I'm going to start right here, and I'm going to name this part of the curve. Because if I name this part, what kind of equation is that? Well, it's a sine because I started on the midline, right? And it's a positive sign because I went up first. Agreed? Agreed. Okay, so I can say that this one is y equals, what's the amplitude? Well, it's a positive 3 because it's a positive sine curve, sine. And I'm going to leave the spot for the b open here for a second. And what's the phase shift? Now remember, the phase shift is the distance between the y-axis and where you started, and that looks like it's 1/2. Okay, so that's going to be x. Whoop, my x looks a little strange. It's going to be x minus 1/2. Why did I put minus? Because what makes this 0? Well, 1/2. Okay, plus 1 because that's my d. Now, how do I find out what the period factor is? Well, you have to know what the period is. Well, the period is going to be this distance here from here to here, because that's one cycle. So what is the period here? Well, how do we calculate the period? We take the last x value here, which is 2.5, minus 0.5, and we get 2. So the period equals 2. But I need what b is. So how do we calculate that? Well, we say, okay, the period has to equal 2 pi over b, which equals 2, right? So I'm going to cross multiply and get 2b equals 2 pi. B has to equal pi. And so that's what goes here. I can erase this now and put pi. And there's my equation. Okay, now, what if I wanted to decide to name it a cosine curve? All right, well, let's do one that has no phase shift. Let's start down here. If I name it a cosine curve name, this equation, do you see how that's a negative cosine? I started down low, went up high, and then back down low. Well, that could be y equals negative 3 cosine. Is the period the same? Is it 2 minus 0? Yep. So the b factor is still going to be pi. X minus 0, you don't have to show this. I'm just showing it for illustration purposes, plus 1. We could name it another name. Let's name it a negative sine name. Let's name this one. Y equals negative 3 sine. Is the period still 2? Yes. So this would be pi times x plus now 2 plus 1. Why is it plus 2? Because what makes this 0? Negative 2, and that's where I started. It's upside down. And we could name this curve infinitely many names with different equations, but I just thought I'd show you at least 3. Okay. Let's do another one. Wow, this one's below the axis, and I don't even know if you can really see the increments there. Oh, but I'll help you out. Okay, so can everybody see that the midline here has got to be negative 2? I mean, even if you didn't know that, you would be able to, negative 1 plus negative 3 is negative 4 divided by 2 gives you negative 2. So if you average those y values, you would get negative 2. Okay? All right, and I think everybody can see the amplitude is 1. What's the period here? Well, I think the easiest one to see is going to be this one here. From here to here, maybe. Do you see how this is one cycle of a negative sine name? And so we're going from 0 to, looks like 2 pi over 3. So the period is 2 pi over 3, which equals 2 pi over b. So what does b have to be? Well, that's no mystery. B has to be 3. Okay, so let's name it a sine curve that's negative. So it'd be negative. The amplitude is 1 sine of 3 times x minus 0 minus 2. All right, because I have no phase shifts. Okay, let's name it a cosine curve. So the cosine curve. Let's, I'll do this color. Let's name this cosine curve from here to here to here. Is the period the same? Yes. Is the midline the same? Yes. All right. So that's going to be a positive cosine 3 times x plus, this is pi over 6. This is negative pi over 6, so it's going to be plus pi over 6, because what makes this 0 is a negative pi over 6, which is where I'm starting, minus 2. And then let's do a positive sine curve. Let's start here. We can't see the whole thing, but we can certainly name it that name. So what would that be? Y equals sine of 3 times x minus, what's the phase shift? Well, I'm starting here at pi, it looks like. So it would be minus pi. Why? Because I make this, whatever is going to, where I'm starting at pi, that has to be what makes this 0. All right, so we just named that curve 3 different names, or equations. All right, last one for this video. Notice that there are no pi's on the axes, which is fine. Okay, what's the midline here? Well, I'm going from negative 2 to 2. Does everybody agree that the midline here has to be 0? Why, yes. And then how do I find out what the period is? Well, I think I'm going to start here and end here. Because that's one complete sine cycle, isn't it? From midline to midline through the up and down. So what's the period? The period is, that looks like 6 minus a minus 6 is 12, which equals 2 pi over b. If I were to solve that, I get 12b equals 2 pi. B equals pi over 6. Okay, so we're going to name that sine curve. So we're going to say y equals, what's the amplitude? And it's positive sine, so it'll be 2 sine of, well, the b factor is pi over 6, the period factor, times x minus, well, what is my phase shift? Well, I'm starting negative 6 away, so this would be plus 6, plus 0, right, because d is 0. Does everybody see that when I make this angle argument 0, it's negative 6? So it's a shift from 0. All right, let's name it a cosine curve and be done. Here's my cosine curve. I don't see the whole thing, but that's okay. That's going to be, it's a positive cosine curve, so it'll be y equals 2 cosine pi over 6. The phase shift here is negative 3, so this would be x plus 3 plus 0. And again, you don't have to show the plus 0. I'm just showing it for illustration purposes, all right? So thanks for being patient with me and learning how to graph sine and cosine by hand using the critical point method. And you have a great day.